In many cases, linear functions present themselves as word problems. So let's make sure we can understand and interpret those word problems in terms of the basic math concepts we've learned so far. How do we take 2 points, form a linear equation? How do we graph that linear equation? How do we take that graph and work backward to understand and find the appropriate linear equations and interpretation? Let's take a look at a couple examples. First things first, note linear word problems will always refer to a constant rate of change. That's what defines a line, that constant slope m. It won't be a percentage change of the current value or fractional change. Given that, you'll be able to recognize in most cases that we're looking at a linear word problem. So let's begin. You rent a bicycle for $20 plus $2 per hour. Essentially, our x variable here is hours. It's time. Our y variable is the entire cost in dollars. So what do we know? It's $2 per hour. That's our delta y, our change in dollars, per unit change in time, which is per hour. And $20 represents the initial, our b, our initial or y-intercept cost. So our graph looks like a y-intercept at x equals or time 0, $20 cost, and we increase at a constant rate of change of 2. Our equation in this case is going to be y equals 2x plus 20, where x represents the number of hours. How about the next one? An auto repair shop charges $50, that's my fixed fee, plus $25 per hour. That's my delta y over delta x per unit change in hour. Same idea here as before. The equation in y equals mx plus b format is going to be y equals the slope, $25 per hour, times x plus my constant or y-intercept, 50. So it's $50 initially plus $25 per hour. What about number 3? A candle is 6 inches tall. This is my initial value. It's the B. And it burns at a rate, a constant rate of 1/2 inch per hour. In this case, we have essentially the height of the candle as a function of time, and our x variable is time. Our y-intercept is 6 inches tall, and it burns 1/2 inch per hour, which means it actually has a negative slope, and it's going down per hour. So what's the equation here? Y equals, our m is 1/2 or negative 1/2 because it's burning per hour. So negative 1/2 t, if t is our time variable per hour or measured in hours, plus my y-intercept of b, which is 6. The equation here is y equals minus 1/2 t plus 6. The temperature is 15 degrees and expected to fall 2 degrees per hour. Here, it's y equals mx plus b. Our m is 2 degrees. It's falling, so that's negative 2 for the slope. And our intercept is 15. So the equation becomes y equals minus 2x, where x represents the hours, plus 15. Okay, number 1, Jimmy's having a birthday party at the zoo. The zoo has fixed fee for birthday parties, plus a fee per person. Often our fixed fee is the b value. The fee per person will usually refer to our slope. Jimmy is told the total charge for 10 people, including himself, will be $97.50. And the total charge for 20 people, including himself, will be $175. Note in this case, we are not given the y-intercept directly. We're not given an initial value at 0 people. We need to determine that. And we can figure that out because, like we saw before, we have 2 points. I have the point 10, comma, 97.50, and the point 20, comma, 175. From this, I can figure out, using our mathematical mechanics, the b value of the linear equation, as well as the slope m. So first things first, I want to set up and understand exactly what my y and x variable represent in the word problem. X in this case is number of people. Y in this case is dollar charge for entrance to the zoo. Okay? So what is my rate of change? Well, it's going to be my delta y over my delta x, which is 175 minus 9750 over 20 minus 10, which is 7750 divided by 10, or $7.75 per extra person. Remember and think about our slope as a rate of change per unit x variable, whatever that x variable is, people in this case. What's the initial value? Well, we don't know that, but we can figure that out. So y equals mx plus b. Y equals 7.75 x plus b. We know the points. Let's put in 20 and 175. So I can say 175 equals 7.75 times 20 plus b. B equals 175 minus 7.75 times 20, if I subtract that from both sides, which is going to be 155, and that equals 20. So our initial value is $20 fixed fee when there are no people going to the zoo as part of your party. So what's the total charge for 17? Well, once I know that, I know my equation. Y equals 7.75x plus 20, and I can plug in 17 for x and figure the total charge. That total charge is going to be 7.75 times 17 plus 20. And this way we can evaluate the linear equation. And that would be a total charge of 151.75. On the flip side, I might want to know the number of people who could come for $500. So my total y value in this case, or charge, would be 500. And I know that equals 7.75 per person times x, the number of people, plus my fixed charge of 20. In this case, I would solve for x. I'll subtract 20 from both sides and then divide by 7.75. X equals 480 divided by 7.75, which in turn equals 61.9 people. Except we have a problem here. I can't take 0.9 people to the zoo. I can't chop one person's hand off and then bring 9/10 of them to the zoo. That would be bad. So what do we do in this case? We do not round that 0.9 up. Logically, we have to get rid of the remainder, and the final answer is 61 people can be taken to the zoo for a total of 500. There'll be some money left over, but that's not enough to pay for the 62nd person. And we'll see that logic at play in various problems on the exam.